Okay. I'm sorry. Sorry I had to schedule it so late.
No problem.
I was baseball. Yeah.
Yeah, no, I know. You're limited as to when you can do these. Okay.
Exactly.
So
Okay.
we're going to draw a picture on number 12.
Okay.
Okay. Here's the mountain. Ooh, what a terrible picture. There's the angle of depression. And when they talk about the angle of depression, they're talking about that angle right there.
Right.
Notice that that's the same angle as that angle. Because they're parallel lines.
Right.
Okay. So this angle is 21 degrees.
Okay.
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 The altitude of the mountain is 1,200 meters. They want to know how far do you ski down the mountain and what is Z? That's what they're asking, is how far can you ski, and that would be what it is, right?
Right.
You've been skiing, you measure the length of the ski slope along the hypotenuse.
Right.
Basically. Okay, so now all you need is a trig function that lets you solve for that. What trig function relates 1,200 to Z?
We could use, sine.
So give me the equation.
Yeah, so it would be sine of 1,200.
No.
Or, I mean, sine of 21, my bad, yeah.
Always take trig functions of angles, always.
Yeah.
You don't have an angle in there, you've made a mistake.
No.
Equal.
Okay. So sine of 21 is equal to 1,200 over Z.
Right. And then you can solve for C.
Yeah.
Okay.
Cool.
I'll let you get the answer on your own.
Yeah, for sure.
Okay. You babysit from noon to 10 p.m. Well, at noon, the hands are like that.
Right.
At 10 p.m., big hand is like that, and the little hand is like that. Right?
Right.
No, I got it backwards. Good God. That's embarrassing.
Oh, you're good. No, you're good.
It's the little hand.
And then the big hand.
The little hand is pointing at 10, correct?
Right.
And the big hand is pointing at noon. Okay. So how far did the hour hand travel between noon and 10 p.m.? In other words, what is this angle right there? That's how far the hour hand traveled.
Okay. So that would be...
What part of the circle is that?
That's the radius.
No.
Right.
The full circle, I would go all the way around to 12, right?
Right.
So this is 10 twelfths. 10 twelfths of a circle. So 10 twelfths times 360.
Oh, okay.
300 degrees. 12 to there, 30. 10 times 30 is 300.
Oh, that's easy. All right.
Yeah, and if you want it in radians, do 10 over 12 times 2 pi.
Exactly.
Well, that's 20 pi over 12, which is 5 pi over 3.
Right.
That's 300 degrees also.
Okay.
And that's all you do on these, is figure out what part, another way to look at these clock problems, that's 1, that's 2. What's each angle measurement? What's the central angle measurement between every hour?
You do 360 divided by 12, which is 30 degrees. 30. Yep, 30.
Now, if I got to go 10 hours, 10 times 30 gives me my answer instantly. But a lot of times in doing these problems, you need this angle.
Okay.
The angle between 1 and 2 o'clock is 30 degrees, also between 2 and 3 o'clock, and so forth and so on.
Right. Cool. All right.
So that was A and B. All right. Let's look at 14. Okay. cofunctions.
Mm-hmm.
What's the cofunction of sine?
Secant.
No, that's the reciprocal. Cofunction is when you take the function and you stick the words co in front of it.
Oh, cosine. Okay.
And what's the cofunction of tangent?
Cotangent.
What's the cofunction of secant?
Cosecant.
Okay, now, here's the rule. The sine of an angle is always equal to the cosine of 90 degrees minus that angle. The tangent and vice versa. The cosine of an angle equals the sine of 90 degrees minus that angle.
Mm-hmm.
So any cofunction has this property.
Okay.
Okay?
Okay.
So they told us that the sine of an angle was 2/3. What's the cosine of 90 degrees minus that angle?
Would you just plug that into your calculator?
No? Look at this. Right there.
Okay.
The sine of x, that's theta, equals the cosine of 90 degrees minus x. Well, there's the cosine of 90 minus theta. There's theta. They both have to equal 2/3. If the sine of x equals 2/3, then the cosine of 90 degrees minus x equals 2/3.
Okay.
It's like, you know that the sine of 30 degrees is 1/2, right?
Mm-hmm.
Well, the cosine of 60 degrees is 1/2.
Right.
Well, notice what that means. The sine of 30 degrees equals the cosine of 90 minus 30.
Okay.
Because of the cofunction property.
Right.
So whatever the sine of that angle is, the cosine of the complementary angle is the same number. Always.
Okay.
In other words, if I told you the sine of 29 degrees was 0.47, then the cosine of 61 degrees is 0.47 also.
Right. That makes sense. So
that's just cofunction properties.
So that's not too bad.
And let's just do 16 while we're talking about it.
Mm-hmm.
What's the answer to 16?
16 would be, so if cosine of pi over 2 minus,
Pi over
so
2,
sine of
2 is 90.
Right. 5 over 2. So sine of theta would be 5/6.
Correct. In other words, it's whatever that is, the sine of theta is the same thing.
Gotcha.
Because the sine of theta is the cofunction of cosine.
Mm-hmm.
Okay. Now we can, that's the last one of those cofunction problems, I think.
I think so,
yeah. Have a look at this one over here.
Okay.
No, I take it back. So what's the sine of 38?
Wait. Oh, where sine of 38 would be 0.616.
Now 17.
I'm sorry. I was looking at the. I was like.
No, that's correct. You got it. I went on because clearly you know how to.
Okay.
17. If the sine of an angle equals the cosine of an angle, what do you know about A and B?
That they're equal to each other, right?
Yeah, because the sine of A would equal the cosine of 90 degrees minus A. And so they're saying that that is equal to that. So I got A equals 90 degrees minus A. Add A to both sides, you get 2A equals 90. A has to be 45 degrees. So it's not just that they're equal to one another, it's that they're equal to 45 degrees. In other words, if A was 100 and B was 100, then the sine of A would not be equal to the cosine of B?
No.
The only time they're ever equal, if you notice on your unit circle, is at 45 degrees. That's the only place, and let's see. I guess they're also equal at 225. So it's not, what do you know about A and B? Yeah, because the sine of 225 is a negative root 2 over 2, and the cosine of 225 is a negative root 2 over 2. So they're either both 45 degrees or they're both 225.
Okay.
There's two answers where that is true. And of course, all of the coterminal angles. In other words, 45 plus 360, so 405 would also be an answer for both A and B. All right.
Multiple answers, okay. Cool.
Yeah, although I'm sure here that you'd probably not lose credit if you just said A and B are both 45 degrees. You might.
No.
You might. No, by missing the 225. I don't think you'd lose credit if you left out the answers that are outside the unit circle, like 405. But I wouldn't doubt that he wants both answers in the unit circle. In other words,
yeah, I doubt it.
The first quadrant one and the third quadrant one. Okay, is there more on this page?
Yeah, let's see here. 18, 19.
Let me scroll down. Yeah, I just hadn't scrolled down, sorry.
Oh, no, you're good.
Now, let me take another picture of it so I can write on it.
Sweet.
I like this writing on this paper. That's turned out to be, yeah, that's been a real godsend because I don't have to rewrite everything on my drawing program.
That's real nice.
Yeah.
Right.
All right.
Like, when did it come with like a new update or something? Or?
No, I just I looked down in the lower right in my tray, and I saw this pen, and I clicked on it, and then realized that what that did was allowed me to take a screenshot of whatever my screen is showing, and then write on that screenshot.
Oh,
so
cool.
No matter what my screenshot looks like, it'll take a picture of it. And in fact, this is one of the few ways I've got my go-to-meeting window blown up, okay?
Right.
You can't see it, just like I don't see yours.
No.
But if I take a picture of it, now watch. This is what my screen really looked like.
Oh, okay.
See the go-to-meeting thing, which I can write on now because it's just part of my picture? So that's...
You can write on anything.
Well, as long as you can take a screenshot of it.
Right.
And
that's real nice. That's real nice.
So I minimize that, and then
Windows
Ink Workspace is what it's called.
Windows Ink Workspace.
Yeah, and now I think you probably have to have a drawing tablet. I don't know what I'd be able to draw on if I didn't have a drawing tablet.
I think you do,
I can draw on the screen. Let me try. No. Might not be.
That'd be really cool if that worked, right?
Well, I guess, yeah. A little scary when you draw on your screen and it makes an imprint.
Yeah, exactly.
You know, these screens, these monitors aren't solid. They're flexible surface.
Oh yeah, yeah.
All right. So if you know the sine of theta, which of the following can you determine?
Cosine of pi over 2 minus 0, or minus theta.
Yep. What is the equation relating central angles in radians, arc length, and the radius of a circle?
I don't know. I missed a few days of school because I was really sick, so I missed a few of these equations that we got.
S is arc length. Okay.
Okay.
There's two equations for arc length. One is this, if theta is in radians.
Right.
And the other is this, if theta is in degrees. Well, if theta is in degrees, I just need that conversion factor.
Gotcha.
So those are your two key equations. And notice that answers exactly what they want. What is the equation relating central angles in radians, arc length, and the radius of the circle? That's it. I guess that's all. I didn't need to write
it,
this
yeah.
other one. Yeah, I shouldn't have written the other one because they asked about radians only. So that one doesn't apply. So if the angle's in radians, then that's the equation.
Okay, cool.
And let's just be clear, you know what I'm talking about when I say arc length. In other words, if I have something like that, there's theta. Arc length is the measurement from there to there. If that were a piece of string and you could cut it and stretch it out, it would be the linear measurement of that line.
Okay.
If you could straighten it out, is what I should say. All right. So, number 20. If a radius of a circle is 2, what's the arc length of an arc with a central angle of pi over 6? So what was the formula again?
S is equal to radius theta times theta.
Okay, now plug in everything.
So it'd be S is equal to 2 times pi over 6.
Which is pi over 3.
Cool.
And that is in units.
It is.
In other words, if it's inches, that's inches. If it's that's feet. Whatever radius is in, that's in.
Okay.
They didn't give us units on this.
No.
Said it's 2. So, okay.
So yeah, it is pi over 3. Okay.
All right. This one, number 21, is based on the same formula.
Okay.
It's just that they give you the arc length, pi, and they want you to solve for r. And the central angle is pi over 4.
Right.
So solve that for r. What's r going to be?
So you do pi over 4 times 1 over 2 pi.
Not quite.
Right? Or no?
Let's do this in 2 steps, and then I'm going to show you the 1-step method.
Okay.
Okay? When you're solving an equation, you always want to get rid of denominators. So the first thing I'm going to do is multiply both sides by 4. That gets that. Okay?
Okay.
Next thing I'm going to do is divide both sides by pi. That's it.
That's all. Okay.
However, we do this so often that the method I use is to multiply both sides by the reciprocal of this fraction. If I multiply both sides by 4 over pi, that's the reciprocal, I know that everything's going away on the right side except the r, right?
Yep.
So I'm going to do the same thing to the left. Now the pi's cancel. I get 8 equals r. So I prefer to do this in 1 step, where instead of multiplying by the denominator and dividing by the numerator, I multiply by the denominator over the numerator. In other words, I reciprocate it and multiply. My goal is to get rid of the pi over 4. I'm going to do that by multiplying by 4 over pi. If this was 3/4, I'd get rid of it by multiplying by 4/3.
Okay. Gotcha. Sweet.
That's probably the last question on that page.
It was, yeah.
Okay.
All right.
That do it for you, or you have any other questions?
Oh, that did it. Yeah, that's awesome.
Okay.
So, awesome.
All right. Dylan, you have a good weekend. I bet you got lots of baseball scheduled.
I will. Yeah, we have a game against Ralston Valley on Saturday at Ralston Valley.
Oh, that's a good day for me to.
So yeah, it's a long ways
bad
away.
Location to come. It's I have a lot of students at Ralston Valley. I probably have 5 students. Yeah, but they all do it online.
Interesting. All right.
Yeah, I've just always gotten lots of referrals from Ralston Valley.
Cool.
Even though they're so far away.
That's really cool.
Yeah. Well, good luck with that game.
Yeah, well, thanks, Mr. Cameron. I appreciate it.
You're welcome.
Yeah, but hopefully we get that win. We unfortunately lost 5-4 tonight on a walk-off, but
does that hurt your chances in the playoffs?
No. We're still in the playoffs. We're still first in our league, which is really good. We're 2 games up from everyone else still.
Okay.
And then so if we win, and then if we win Saturday, it just puts us in a better spot for the playoffs. So.
Good.
Yeah, we'll get that win, so that'll be cool.
Good luck.
Yeah, thanks, Mr. Cameron. I appreciate it.
Talk to you later, Dylan.
Sounds good. Thank you.